Hey guys, thank you for coming on board. We'll just hang on a minute, see if everyone else wants to join the stream. Sorry I'm a little bit late, I had a bit of trouble getting the stream set up, but we'll get going in a minute. Just if you're in chat, say hello, let me know who you are, and we'll get going. So we're going to be on Scratch today, so if you want to join in, you can get yourself on Scratch. Hey Casey, good to see you. Okay, who else have we got? Right, so we're going to be looking at some prime numbers today, so I want you to have a think about what prime numbers are, and maybe that'll help us out today. So you need to dig deep into that math knowledge you've got, think about what a prime number is, and we're going to use Scratch today to think about how we can find prime numbers using Scratch. So I've got a couple of ideas already that I'm going to try out, see how they work. Right, so let's get going, guys. So let's get Scratch loaded up, and I've got a fresh Scratch here. The only thing I've added to it is I added a little speech bubble that made him say prime numbers, but I don't need that at the minute. So first thing I want to think about then is what is a prime number? And so a prime number is a number that can, well, there's a couple of ways. We can either think about it by dividing, or we can think about it by multiplying. So if we think about it in terms of dividing, it's a number that can only be evenly divided by 1 in itself. So for example, if I say that 5 is a prime number, so the only numbers that can divide 5 are 1, because 5 divided by 1 is 5, and 5, because 5 divided by 5 is 1. If I try to divide it by something like 2, 5 divided by 2 gives me 2.5, and it's not a whole number. So we're looking for numbers that can only be divided into whole numbers by themselves and 1. Or we can look at it from a multiples point of view, and I find this an easier way to look at it, is that the only factors that we have for primes are 1 of themselves. So I can only make 5 by doing 1 times 5. I can't make 5 any other way. I can't do 2 times something or 3 times something. The only way I can make 5 is 1 times itself, or 1 times 5. So that's kind of how I'm going to think about my primes, and those are the numbers we're going to try and identify today. Now, I have a way of remembering all of the primes up to 20, and it's quite a peculiar way, I think, but I think it works, and that is to think about all the numbers that are not prime, and if I know all the ones that are not prime, then I must know all the ones that are prime. You'll see what I mean. So I'm going to just write out the numbers 1 to 20 first of all, so we can figure out which ones are prime, which ones are not prime, and we'll go from there. Hey Finn, thanks for joining in. So let's get, actually I want to write a note. I'm going to add a comment. Yeah, perfect. So here's my little notepad that I'm going to use to write all the numbers 1 to 20. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Okay, so all those numbers all the way up to 20. Now, I'm going to start eliminating some numbers here. I'm going to start getting rid of some. Hey Charlie, thanks for joining me. We're going to have a look here at all the even numbers to start with, because I know there's a fact I know that the only even prime ever is 2. 2 is the only even prime. So every other even number, I can get rid of it straight away. So I can get rid of 20, I can get rid of 18, I can get rid of 16, I can get rid of 14, 12, 10, 8, 6, and 4. All those even numbers are gone. They're definitely not prime. And the reason they're not prime is because they're all in the 2 times table. So they've all got 2 as a factor. So, it can't just be 1 in itself, it's got 2 as well. So the reason 2 works is because it's got 1 and 2. You can only make 2 by doing 1 times 2. Makes sense. So now we've got just the odd numbers and 2 left. Now 3 I can only make by doing 1 times 3. There's no I can't times 2 something to make 3, so that doesn't work. So 3 is a prime. 5 is the same, we've already said this one. 7 is a prime as well, because you can only make that with 1 times 7. There's no other times table with 7 in it. 9, however, 9's an interesting one. 9 isn't a prime, because you can actually make it by doing 3 times 3. So you can do 1 times 9, but you can also do 3 times 3, so it's not a prime. In fact, because it's multiplying a number by itself, 3 times 3, that is actually a square number. So we might look at those another day, but that's a square number, so I'm going to get rid of that one. Right, and then I've got 11. Okay, there's no times table that's got 11 in it. I've got 13. There's no times table other than the 13 times table with 13 in it. But then I've got 15. Now, have a think. What times table do you think has got 15 in it? So put it in chat for me. What times table has got 15 in it? So think about your times tables and which one has got 15 in it. So something times something does equal 15. It's not prime. I'll tell you that now. So thinking about that, put it in chat for me, guys, if you've got it. We got it in chat yet? Hopefully we have. Right, okay, so I've got, yes, I have, right, 5 times 3. Yes, thank you, that's awesome. Okay, so we've got 5 times 3, which is obviously not 1, you've got 1 and 15, you've got 5 times 3, so that's fantastic, we've got those two. Oh, has my stream gone down for a second there? Are we back? We're back, okay, cool. So, yeah, we can make this by doing 5 times 3, so it's in the 5 times table and the 3 times table, as well as being 1 times 15. So that one's not prime. So we are now left with 17, which is a prime, and 19 that's a prime. So here's how I remember it, guys. It's all the odd numbers apart from 9 and 15, which we've just been over, but there's one more odd number we need to get rid of. Do you know how I said every one of them has got 2 factors? So we've got 1 times 2, 1 times 3, 1 times 5, 1 times 7, 1 times 11, 1 times 13, and we've got 1 times 17 and 1 times 19. They have all got 2 factors. We've got 1 and 2, 1 and 3, 1 and 5, 1 and 7, 1 and 11, 1 and 13, 1 and 17, and 1 and 19. Now if we look at 1, the only way to make 1, the only way to multiply to make 1 is to do 1 times 1. And what that means is 1 has actually only got 1 factor. It's 1. It hasn't got 2. So it doesn't qualify to be a prime. Now this is a mistake loads of people make, is they think that 1 must be prime because it's 1 in itself, but it's got to have 2 factors, and it's only got 1, so 1 isn't prime. So it's all of the odd numbers up to 20 apart from 1, 9 and 15. If you can remember that, you've got almost all of the primes up to 20. The only other one you've got to remember is the only even prime, which is 2. Okay, so now we've got our list of prime numbers, so I'm going to just keep that handy because we're going to use that. Okay, good stuff. Right, so let's start thinking about a program that could recognize whether a number is prime or not. We could have like a prime testing machine. Let's see. Okay, I'm going to need to put an input into my Scratch program today. I'm going to have to be able to type something in to test whether it's prime or not. So the first thing I want to do is I want to see if can I make that input. So if you go to sensing, you'll find there's actually an ask block. So ask what's your name is what it comes up with. This is going to allow us to input a number to test whether it's prime or not. So let's go for what is your number. So we're going to ask the user, the person using the program, to put in a number. Okay, so let's just test that to begin with. So when we click go, when we click the green flag, what is your number? And so you can see it pops up, what is your number? And then it has a little text box at the bottom, which means I can type in a number, and I could type in a number in a minute, and nothing's going to happen because I haven't got an algorithm after that says anything's going to happen, so it just stops there. But what the computer does do is it stores that value. So within the program, it's going to store that 4, or whatever I type in next time, it'll store that 6, let's say. Okay, so we've allowed them to enter a number. Now we want to see if we can check, is this a prime or not? Okay, so we're going to check to see if this is a prime or not. So, hey Harrison, thank you for joining us. Let's start the bit of code here now. I'm going to go a bit into the unknown here because I think I can make a list. And now this is something I don't do very often in Python, but I reckon you can make lists. Now we're going to experiment here. This might work out and it might not. That's part of programming. I'm going to see if I can figure it out. So I'm going to make a list, and my list is going to be called prime numbers. Okay, cool. So my list is currently empty, and it says I can add to this list. So let's put in those prime numbers that we figured out before. So we've got 2, 3, 5, 7, not 9, remember, because that's 3 times 3. We've got 11, 13, 17, and 19. So those are our prime numbers up to 20. There are some above 20. Of course, there are loads above 20, but actually those are the ones I'm going to focus on today, the ones up to 20. Now I wonder if I can use that list. Oh no, look, I've got all these blocks now. Right, so I'm going to leave that list up for a minute, just while we're working on it, but then we'll maybe hide it later on. And I've noticed in this block here, contains thing. Prime numbers contains thing. This is going to be mega useful for me. I think this is going to work out just perfectly, because we can use that block to check if their answer is in my list. Now, I said it stores the answer, and it does. And if you go to sensing, you'll see that there's this little round answer block, and that is going to be perfect because you'll see it's the same shape as that, which means I can just pop it in like so. Easy. Okay. Now, it won't go attached to that though, because we need to give it a condition to do that with. So we're going to go to events. No, we're not. We're going to go to control. I'm going to go to if then. And again, we've got that shape that's given us a bit of a clue that this orange block is going to slide in here. Is it ready orange? I don't know. Okay, so we've got if prime number contains answer, and then we can do something. So we could say something. So let's do that. Let's go looks. Let's say yes, that is a prime number. Okay, cool. Let's test it. We've got a little algorithm. Let's go. So I click go. It says what is your number? So let's put in a prime number. So let's put in 7. We know that's a prime, and press enter. Awesome, it comes back, yes, this is a prime number, but we better check with one that isn't in the list first. So I'm going to pick a number that is odd but isn't a prime. So I'm going to pick that square number we talked about earlier. I'm going to pick 9. Right, and it doesn't do anything, which is good, because it didn't say it was a prime number, but it's not great, because I think we could build a better program if it said, no, that's not a prime number. So we're going to change this if block actually, because we want more than one option. We're going to change it to an if then else that gives us a bit of an option after if it's not. So I'm just going to move this stuff across, get that back. Okay, so now I've got if the prime number contains their answer, so if this list contains their answer, then I say yes, that is a prime number. Must remember to punctuate my sentences. Okay. Can't ever forget, English is always important. Then I could say no. I could have a no. So if it's not in the list, we could say no. Oh, that is not a prime number. Awesome. full stop. Let's test that out then. So we need to get one right, one wrong, just to check this is working again. So let's try a different one. Let's try 5. So this should be a prime. Awesome, that's a prime number. And then let's try again. Let's try with one that's not. So let's go with 15. Awesome, guys. This is working so well already. I'm really happy with this. This is great. Okay, so what I could then do is I could actually hide my list, because I don't want to give away my prime numbers before they've tried the program. So I'm going to just double click on that. My list is gone. Fantastic. Right, guys. So, oh, hi Alex, thank you for joining in. Right, so guys, we've got a really good program there. It tells me whether the numbers are prime or not, but only up to 20. I wonder, could we go really advanced on this? Could I get it so that actually, instead of just using a list, can I get it that it checks any number to see if it's prime or not? I wonder, this could be good fun. Let's have a go. Let's have a go. Right, okay, so we've got this program, and I'm just going to put Scratch to one side, and I'm going to get a brand new sprite to try this out with. So I'm going to choose a new sprite. I need somebody mathsy. Who do I think is going to be my best maths representative? I could have a bear, the maths bear. What do we think? Oh, I want a math dinosaur. 100% math dinosaur. Oh yes, there he is, Triceratops. That's the guy for me. Right, we're having a math dinosaur. Here he comes. Right. Now, we're going to try this out, guys. It might not work first time, but we'll make it work eventually. So we're going to get them to put in a number, and then we're going to do a test to see if that number's prime. So first thing I'm going to do is exactly the same. Is I'm going to think about asking them a question. Say, what is your number? So there's going to be the similar start. What's your number? Question mark. Oh, did I put a question mark on the first one? Yes, I did. Thought I'd forgot my punctuation again then. Right, okay, so what is your number? So we're going to let them put the number in, and then we need to test that number. So let's think. We're going to take their answer, and we're going to need to divide it by every number lower than that answer, and see if it gives us a whole number. So there's quite a lot of complicated program going on here, so I'm going to have to think very carefully about my next steps. So I want to take their answer, and I'm going to want a new variable, and the variable is going to be used to divide the answer, but then I'm going to change the variable as it goes. So I'm going to make a new variable called div number. So it's my division number. I've just shortened it because programmers are lazy, but there we go. I've got a div number. So once they've given their answer, I want them to set the division number to not the answer. I want the answer minus 1, because I don't want to divide it by itself. We know that works. We don't need to test that. I want to do the answer minus 1. So I'm going to need to go to operators, and I'm going to get the minus block. So set the div number to answer minus 1. So we'll start with a low number just to sort of check this is working. I'm just going to disconnect this sprite for a minute so it doesn't get in our way. So I'm just going to disconnect you so you don't accidentally start talking. Okay, so all we should do at the minute is ask us for a number. We'll give it a number. So let's say we do 5 as a nice low prime. We press enter. Right, and div number seems to have gone to 6. Well, if I typed in 5 like I thought I did, that doesn't seem to be right. Let's just check again. Let's make sure we set div number to 0 at the start. Okay, let's try that again. It's gone to 6. Set div number to minus. Oh, I put minus 1. So hopefully this time it will go to 4, and it does. Perfect. Now we're going to start doing some tests. I'm going to start doing their answer divided by our div number. So we'll do 5 divided by 4 and see if it works. So I need to see how I can do that. Ooh, this is exciting today. I like it. I like it. How are we doing? How are we doing, guys? We're doing all right. Right. Okay, so I think I've got an idea. We're then going to need the operators block, and we're going to need to divide. So that's the divide symbol on computers. It's that /. And we're going to need the answer again. So we've got to try and think about how we do this in Scratch. I know what I want to do, but it's about finding the right blocks and code for how to do it. I want to divide the answer by the div number and see if it's a whole number. Now the question is, can Scratch check for a whole number? I don't know. I don't know. Where do we want to put that? Oh, I know I want to do that calculation. So, have we got a block that says it's a round number? Oh, we've got lots of exciting mathematical terms here. I can't see one for integer. I want it to be an integer only. Don't think that's integer. Could be wrong. Okay. So, let's see. We know we've got that, and then I want to carry out that calculation. So answer divided by, and I want an equals block. Where's my equals block gone? There. So I can then say if the answer to this is equal to, and here's where I need to figure out, can I ask it to say a whole number? Because that's really what I want to check. Or do I need a range of numbers? I could do that. I could probably do a range of numbers. That would work quite well. Let's see. Do I need another list? I could do another list of numbers from 1 to 100. This is an interesting problem. So, I'm not 100% sure I've got what I need to be able to do this. So let's have another look. I might have to go and have a look on some help files, see if I can find it. I'm not sure Scratch could do this, but maybe it can. Surely it can. If you guys have got any ideas, you can put it in the chat, and I will happily give it a go. See, let's have a look. Nope, can't see that there. Okay, let me have a look, guys. Let's have a quick look at this. Here we go. So, integers in Scratch. So we're going to have a quick Google of this, guys. By the way, guys, if you've joined me, I do really appreciate it. Please do give the stream a like when it's up as a video. Share it. Let everyone know that I'm doing these. I'd love to get more people involved. So let's see if we can get this figured out, and then we can share it, and everyone can make this. It'd be really cool. So, oh, okay, that might work for us. I found something that might work for us. Okay, let me try. I've got a few things that might work. let's give it a go. So it's suggesting that I might be able to do this. I'm going to have to get another variable, I think. So let's make a new variable. Let's try this out. Let's go division answer. So if the division answer is, so set division answer to this. Oh. Okay, cool. So I'm saving the answer to that division there, and then I'm going to use this block here. I think. Let's try. Yeah, let's try. Right, what I'm going to do is I'm going to, right, I reckon I've got it. So, if I round that number, so if I take my division answer and round it, and then see if it's the same as the number I started with. So if I've rounded it and it's the same number, then it must have started off as a whole number, whereas if it's a decimal and I round it, it will change and it won't see it as the same number anymore. I'll see if I can explain that with an example in a minute. So if the division answer rounded is the same as the division answer went before you rounded it, then we're going to say yes, no, it's not a prime. Although it's a bit early for that because we've only done one check so far. So we've done 5 divided by 4. We need to do 5 divided by 3, 5 divided by 2 until we get down to 0, or until we get down to 1 rather. So we're going to need to, if they don't equal, then we need to go to the next number in our division number check. So we're going to change the division number. So I'm going to run through this algorithm now, guys, because I know that we've done a lot there, and it's brand new to me, and I'm just trying to make sense of it. And I know it's a little complicated, but you know, I'll explain it now, and hopefully it'll make some sense. So we've got we start off and we've got this number that we ask for. So we've got here ask what's your number. They're going to put in a number for us. So let's go for the number 3 because that's going to be a nice low one for us to work with. Okay. So we put in that number 3, and from that we make our division number. So we're going to divide 3 by this division number to see if it's prime. So we're going to do 3 divided by 2 to find out if we get an answer that is a whole number. If we do, we know it's not prime. So it's done that, it's divided it, and it's given us this division answer, which is 1.5. It hasn't divided to a whole number, so it could be prime. But then we need to divide it by 1 as well, just to double check. So we need to go divide it by 2, divide it by 1. If that works out, we know it's prime or it's not. In fact, let's do another number. Let's do 4. So 4 we know is not prime. So when I divide that by 3, I get the answer of 1.33333. It's going to round that here, so it takes that 1.33333 recurring, and it rounds it to the nearest whole number. So that would become 1. It rounds it down to 1, and then it checks: is it the same as what we started with? So is it the same? Now I've rounded it down to 1. Is 1 the same as 1.333 recurring? No, it's not. And so because it's not, no, I might have made an error here, mightn't I? Because it's not. This is why you need to talk through your code, guys. So if it is the same, then we're going to say it is not prime. Yeah, absolutely. If they're the same, then it's not prime. So let's go to looks. And let's say that number is not prime. Okay. Now I'm going to need that if else block. I'm going to need that extra option, aren't I? So let's just get rid of that. I should just get used to the habit of just having that extra option. Okay. So if they are equal, and so it has divided to a whole number, then we know it's not prime. Otherwise, I want it to take the division number down by 1 again, and then I want it to loop back to the start. Now, we're going to need to think about some repeat until here. Right, so we're going to repeat until we're going to go from the number they put in all the way down to 2. We don't want to do 1 because 1, everything divides by 1. So we don't need to check that one. We need to check from the number they gave all the way down to 2. So we're going to go until the div number is equal to 2. So we're going to go until the div number is equal to 2. Right, let's give that a go. Let's see if it works. So let's put in 5 again and see what happens. It might happen very quickly. Okay, so div number went down to 2. Let's put a wait in there so we can try and see it happening as it goes. So let's put a 5-second wait in there. It's quite a long wait. Let's put it there. Okay, cool. Let's put in 5 again then, and let's watch it happen. Now the key bit is going to be happening at the top here with these numbers. So let's put 5 in. So it checks 4, and then it moves it down to 3, and then it moves down to 2. So what's happening here is, let me move the weight actually, I'm going to move it just to there. Okay. So what's happening here is, I might need more than 5 seconds to explain this. So we start off, I put in my number 5, it takes 1 away and then it does 5 divided by 4. It finds that the answer is 1.25, so it says, right, it's not the same, it's not a whole number, so I'm going to change the div number down by 1 to 3, and then I'm going to do 5 divided by 3 and see if that's a whole number, and it's not, and then I do, now have I done something wrong? I think I have. Yes, I think I need to include this into my loop. I think I've made a mistake somewhere, because I'm changing the div number, but I'm not dividing the answer by the div number over and over again. I'm only doing that once. Division answer. Okay. So the answer would be 5. We divide that by 4. But then I need to change that to 3. So I need to have this block in here somewhere. Division answer. Okay. Let's try moving this block inside, because I think I've made a mistake somewhere and I want to check it out. Okay, let's try a higher one. Let's try 7. So it does 6, so it's dividing it by 6. And then it divides it by 5. Yes, so we can see our division answer number is changing here. So as long as it's got a decimal, it should be prime. And so we'll see it divided by 4. That's still a decimal. Okay, let's see if it divided by 3. Yep, still a decimal. So then the last one should be 2 and it should stop. Gosh, we are doing some hard maths today, guys. I tell you, I'm having a brain workout on a Monday. Right, they were all decimals. We know that the number I started with was prime, so that's should have worked. Okay, if it gets all the way to the end and it's got to here, then it'll then all of its repeats, it will come down to here. So I'm going to put in a thing here that says that number is prime. And I think we're ready to do some serious testing. Right, guys, let's give this a go. So let's put in a number we know isn't prime. So we're going to put an even number in. We'll put in 20. Let's put in 20. And let's just watch it as it goes through. So it divides it by 19. Oh, actually, I want to take my wait 10 seconds out because that might be a bit long. So let's just speed it up a little bit. Let's put 2 seconds in. So it should do it pretty quickly now. Divided by 19 is a decimal. Divided by 18 is a decimal. 17 gives us a decimal. Dividing by 16 gives us a decimal. So I'm expecting when we divide it by 10, it will find that it is not a decimal, and it should find that the rounded number and the answer are the same. There should be 2. Yes! Okay, guys, did you see that? So it said that number is not prime. In fact, he keeps saying it. He is so adamant that it's not prime. So that works. That is so cool. I love that. That's really good. So it appears to be working. I'm not quite sure why he keeps saying it. Oh, he keeps looping back round. He keeps, because I'm not changing the div number. So let's put an end in there. So let's just stop it when it gets to there. Otherwise, he'll keep saying that for eternity, and that's no life for a dinosaur. Let's put a stop all in there. Okay, cool. That's awesome. I love this. This is so cool. Right, okay. I'm going to get rid of the weight because I want to do some heavy duty testing and I want to do it as quickly as possible. So I'm going to get rid of the weight. Okay, cool. So let's run through our numbers that we know from 20 to 1 and see if it's prime. I think I might have one problem here. So 20, not a prime number. Awesome. Did it almost instantly. Right, 19, which we think is prime. Yes. All right. Okay, let's go. 18, not prime. 17, that's prime. Okay, 16. That's not a prime number. Yes, it is. Correct. It's not a prime number. Now 15. 15 is a tricky one to remember because it's 3 times 5, so it's not prime. Yes. Okay. Awesome. Forgot my full stop. Guys, forgot my full stop. 14, not prime. Good. 13 should be prime and is prime. Awesome. 12, not prime. 11, prime. Good. 10, not prime. 9 should be square number. Remember, 3 times 3, so it should be not prime. Oh, not prime. Awesome. 8, even number, so not prime. 7, we've checked and that one works. 6 is an even number, it's in the 2 times table, so that's not prime. 5 is prime. 4 is prime. 4's prime. Hang on a minute. 4's not prime. 4's not prime. Ooh, we've got a problem, guys. So good job we did our testing. Why didn't it do that? Maybe I need to move until my div number is 1. So it does 2, but it doesn't do divide by 1. Let's try that. 4. Okay, so now it says 4's not prime. I wonder if all the others still work. 3 is prime. 2 is prime. Good. Now I'm a bit worried that 1 is going to say it is prime. Let's see. Oh yes, it says it's not prime. Okay. Oh, but I got infinity there. Infinity. That's amazing. Oh guys, this is such a cool algorithm. I love it. Hey guys, thank you for staying in and following along. I know it's been a really tricky one today. I've enjoyed just the problem, but hopefully you'll be able to kind of follow along. Hi Emily, thanks for joining in. So let's just test very quickly those numbers again, just make sure that I haven't changed anything too dramatic. And then what I want you to do, guys, is I want you to throw some numbers into chat that I can check, see if they're prime or not. I want you to just throw me some numbers and then we'll see if they're prime or not. So put them in while I just check these. They're still right. Yep, 16's not prime, 15 not prime, good. Oh, I'm impressed with myself here. This one's prime, yep, 13's prime, 12 shouldn't be. Okay, 10, not prime. 9, not prime, yep, 8. Let's try that again, 8, not prime. 7, prime. 6, not prime. 5 is prime, and 4 was the one that got us in a bit of trouble before, is not prime. Okay, awesome. So all the ones up to 20 work. So now I can start trying higher numbers. So for example, I know that it's not going to be any even numbers because the only even prime is 2. But if I wanted to try 21 out, so the first odd number after 20, and see if that one's there, it's not prime. Now if I think about that, actually I know 21 is in the 7 times table, 7 times 3, it's in the 3 times table. So, okay, let's try 23. So that one is prime. Awesome. What about 27? 27's not prime. Can we think about what times table is 27 in? Put it in chat, guys, if you think you know what it is. What times table is 27? Let's try 29. 29. So that one is prime. Okay, so 27. What times table is 27 in, guys? Help me out, guys. I can't think of it. Oh, right. Oh, great. I've got some numbers in chat to try out as well. Great. Okay, so, oh, right. Okay, so Finn's put in 50. So let's try that out. Finn's put in 50. Let's give it a go. Now, I suspect this is an even number, Finn, so I think I know already that it's going to be not prime. It's not prime number, because it divides by 2 and 10, amongst other things, and 5. So what else we got? We've got Emily puts 11. Let's test out 11. Okay, 11 was prime, yeah? Yep, that number is prime. Such a wise dinosaur. Oh, Emily's gone for 108 as well. Now again, that's an even number, so I'm pretty sure it's not going to be prime. And it's not prime. Good, it works. Awesome. 9 times table. Of course it is. Yes, guys. 27, 9 times table, 3 times 9. Thank you, Harrison. That was really good. Emily, let's go for 89. And we'll try yours, Harrison. 89. 89 is apparently a prime number. Fantastic. What was yours, Harrison? Yours was 137. Apparently that's prime. My dinosaur says so, and I believe my dinosaur. I think his algorithm is good. Okay. Right, guys. So, do you know what? I think we've done a cracking job there today. I'd love you to have a go at building this yourself. I know it's a bit complicated, and if there's anything you're not sure of, you can ask me in the comments and I'll try and explain it as best I can. But this is a really nice tool for finding prime numbers. We could use it to check out some numbers, see if they're prime or not. Harrison, I need you to get Freya to check that if this all works, because she knows her prime numbers. We know this. But again, let everyone know, guys, that these lessons are happening. I'd love anyone to join in, any year group, doesn't matter. Share it with your mates, let them know it's happening. Give it a like, that means more people will see it. Please put a little comment in if you've really enjoyed it. But what I really want to know is, before we go today, is what would you like to do tomorrow? So I've had a couple of ideas. I've got a racing game, sort of like a top-down racing game that I'd quite like to try and make. I'm not sure how it's going to work, so I know we'll have to try and figure it out, but I'd quite like to do that one. Or we can do sort of a Flappy Bird or Geometry Jump sort of game. Geometry Dash, sorry. So a game where sort of obstacles come across the screen and you've got to like dodge them by jumping or flying or whatever. So those are the couple of ideas I've had. So any ideas you think you'd like to have a go at? So which one of if you've got a different idea that you'd like me to have a go at doing on stream, or if you like the sound of one of those ideas, you can either put it in chat now or you can put it in the comments later. And we'll go with whatever you guys want to do. But thank you ever so much for turning up. Thank you very much for all your contributions. Alex, thank you for that. I will have a look at your game in a moment. Just when I finish the stream, I'll have a little look at it. Alright, okay, so Finn would like Star Wars or Spider-Man theme. I'm sure we could do that. I'm pretty sure I could do a Star Wars racing game. Oh, Harrison likes a role-playing game. Now, I'd love to do a role-playing game. That'd be really cool. I wonder... It's very doable. It's very doable. It's quite complicated, but we can definitely have a go at doing that. I'd like that, Harrison. Right, so I think I'm going to end the stream there, guys. I'm actually going to pop back quite shortly back onto a stream where I'm going to do some Python work for year 7 and 8. So you're more than welcome to jump into the stream then. I'm just going to be recording them as lessons, but I thought I'd do it live at the same time. So if you see my channel pop back up again, that's what I'm doing. But thank you very much for joining in, and hopefully I'll see some of you guys tomorrow. Look after yourselves, guys. Bye.